Have you ever wondered how computer programs used to function in the era before multitasking? We're going back in time to explore the world of Terminate and Stay Resident programs, or TSRs. In the early days of personal computing, operating systems were far from the multitasking powerhouses we know today. Enter the world of TSRs, or Terminate and Stay Resident programs. These cleverly designed pieces of software would execute their primary function, then instead of exiting entirely, they'd remain resident in the computer's memory, ready to be reactivated without the need for reloading. This might seem simple, but it was a game changer in the time of operating systems like MS-DOS, which lacked the advanced multitasking capabilities we take for granted today. TSR programs were like the multitasking pioneers of personal computing, allowing users to rapidly switch between different utilities without the delay of reloading each one from storage. TSR programs were not just about staying in memory though. They were also about preserving their state and data. This meant they could pick up right where they left off when reactivated, making them incredibly efficient for their time. These programs were like chameleons, seamlessly blending into the operating system. They used interrupt hooks to take control during certain events or functions. When an interrupt occurred, the TSR program could swoop in, execute its code, and then pass control back to the operating system, almost as if it was part of the OS itself. But TSR programs weren't just passive bystanders. They could be designed to respond to specific triggers, like hotkeys or certain events. When triggered, they'd spring into action, performing their function with speed and efficiency. Whether it was utility programs, memory management tools, screensavers, or print spoolers, TSR programs were the unsung heroes of the MS-DOS era. They might have required careful management of system resources, and yes, they could lead to system instability if conflicts arose, but they were an ingenious solution to the limitations of early computing. Thus, TSR programs, though simple in concept, played a significant role in the early days of computer computing. Now that we understand what TSR programs are, let's delve into how they work. Imagine having a juggler on a stage. The juggler begins by loading balls into his hands, representing the TSR program being loaded into the computer's memory. Once all balls are in motion, the juggler then relinquishes control back to the stage, much like a TSR program relinquishing control back to the operating system. But instead of exiting the stage, our juggler remains, balls still in the air, ready to resume juggling at a moment's notice. This is the essence of a TSR program, preserving its state and data in memory. It allows the program to resume its operation quickly when reactivated, enabling users to switch between TSR programs without experiencing the delays associated with reloading from storage. Now, imagine if our juggler could also respond to certain events, say a particular clap from the audience or a specific spotlight color. This is akin to the interrupt hooks used by TSR programs. When an interrupt or event occurs, the TSR program can intercept it, execute its code, and pass control back to the operating system. Furthermore, TSR programs can be designed to respond to specific triggers, such as hotkeys or certain events. Like a juggler responding to a whistle by performing a special trick, when triggered, the TSR program activates and performs its function. However, just as our juggler must carefully manage his balls, TSR programming requires careful management of system resources. Conflicts between TSR programs could lead to system instability, and since these programs reside in memory, they can consume a portion of the available RAM. Finally, just as our juggler can exit the stage when his act is over, TSR programs often provide a mechanism for unloading or deactivating themselves. This allows users to reclaim memory and system resources when the TSR program is no longer needed. So as you see, TSR programs were quite an ingenious solution to the limitations of early computer systems. TSR programs weren't just a fancy trick, they had some serious applications in the world of computing. One of the most common uses of TSR programs was as utility programs. These are small, helpful programs that perform a specific task to make the computer user's life easier. For instance, a TSR utility program might provide a quick calculator or notepad that could be pulled up with a simple keystroke, no matter what other program was currently running. Another popular use of TSR programs was for memory management. In the early days of computing, memory was a scarce resource, and managing it efficiently was crucial. Some TSR programs were designed to optimize how memory was used, freeing up space and making the computer run more smoothly. Screensavers are another example of TSR programs. These programs would kick into action when the computer was idle, displaying moving images or patterns to prevent screen burn-in. While this might seem like a minor detail, it was actually a significant issue with early monitor technology. Print spoolers were also commonly implemented as TSR programs. A print spooler is a program that manages printing tasks, queuing up print jobs and sending them to the printer one at a time. By making the print spooler a TSR program, users could continue working on other tasks while their documents were printing. And the list goes on. TSR programs were used for a wide variety of tasks, from managing networks to controlling hardware peripherals. These programs were a critical tool for overcoming the limitations of early operating systems and making computers more user-friendly and efficient. But it wasn't all smooth sailing. TSR programming required careful management of system resources, and conflicts between TSR programs could lead to system instability. Additionally, these programs could consume a significant portion of the available RAM. Despite these challenges, TSR programs were a key part of the computing landscape during the MS-DOS era. They allowed users to multitask before multitasking was a built-in feature of operating systems, and they paved the way for many of the conveniences we take for granted today. TSR programs, therefore, played a critical role in enhancing the functionality of early computer systems. However, like all good things, TSR programs had their share of challenges. Despite their utility, TSR programs were not without their pitfalls. These programs required a delicate balance in managing system resources. Since they were designed to remain resident in memory, they could consume a significant portion of the available RAM. This was particularly problematic in an era when memory was a scarce and valuable commodity. Moreover, TSR programs could potentially conflict with each other. Each program would hook into the system's interrupt table to gain control over certain events or functions. If two or more programs attempted to hook into the same interrupt, it could lead to conflicts, causing system instability or even crashes. Programmers had to be meticulous in their design and coding to avoid such conflicts, but the risk was always there. Now let's turn our attention to multitasking environments, a significant development in the world of computing. Multitasking allowed multiple applications to run concurrently, switching between them as needed. This was a game changer, and it made the concept of TSR programs less relevant. In a multitasking environment, each application has its own dedicated area of memory and can be quickly switched in and out of the active state. This made it unnecessary for a program to remain in memory after its initial execution, as was the case with TSR programs. In fact, modern operating systems, such as Windows, macOS, and Linux, have taken multitasking to a whole new level, offering sophisticated memory and process management. They provide mechanisms for managing applications and processes that are far more advanced than the TSR approach. In the light of these advancements, TSR programs began to decline. They were no longer the optimal solution for quick program reactivation, and their limitations became more pronounced. Programmers started to favor the more flexible and efficient multitasking capabilities of modern operating systems. With the emergence of modern operating systems, the era of TSR programs came to an end. But as we'll see in our next scene, their legacy lives on in the principles and practices they helped to shape. TSR programs might be a thing of the past, but they left a lasting impact on the world of computing. With their ability to remain resident in memory after execution, they offered a form of multitasking in an era when operating systems were still growing in complexity. One of the critical legacies of TSR programs lies in the concept of DOS extenders. These were essentially software bridges that allowed TSR programs to access more than the standard 640 kilobytes of conventional memory in the MS-DOS environment. This was a game changer at the time, pushing the boundaries of what was possible within the confines of the then existing hardware and software limitations. TSR programs also pioneered the concept of unload mechanisms. These allowed users to deactivate TSR programs when they were no longer needed, freeing up precious system resources. It was a crucial step towards the efficient management of system resources that we see in modern computing systems. But perhaps the most significant impact of TSR programs was in how they set the stage for the development of modern multitasking operating systems. By remaining resident in memory and preserving their state, TSR programs allowed users to switch between different tasks without reloading each program from storage. This was a rudimentary form of multitasking, but it paved the way for the sophisticated multitasking capabilities we have in today's operating systems. In the grand scheme of things, TSR programs were a stepping stone on the path to the advanced computer systems we use today. They solved a problem of their time and, in doing so, led the way to new solutions and innovations in the field of computing. Though no longer in use, the legacy of TSR programs continues to influence how we design and use software today. They serve as a reminder of how far we've come and a testament to the endless possibilities of technological innovation.